Welcome to Machine Learning. Today we will cover AI versus ML versus deep learning, real-world applications, and the types of machine learning. Let's start with definitions. Artificial intelligence simulates human intelligence like reasoning. Machine learning enables systems to learn from data without explicit programming. Deep learning uses neural networks for large datasets. For example, AI powers chatbots, ML runs recommendation engines, and DL enables self-driving cars. How do they process data? AI automates tasks using systems like virtual assistants. ML uses models to predict outcomes based on data patterns, like spam detection. DL handles abstract features for face recognition and voice assistance. Comparing features. AI has the broadest scope, ML is a subset, and DL is a further subset. Complexity and hardware requirements scale up heavily to deep learning, which is highly GPU intensive. Machine learning drives real-world industries. In healthcare, it handles disease diagnosis and medical imaging. In finance, it assists with fraud detection and algorithmic trading. For transportation, it optimizes routes and traffic predictions. Finally, in cybersecurity, it provides critical intrusion and malware detection. What is supervised learning? It trains models on labeled data, learning input-output relationships to predict unseen datasets. The process follows 5 steps: inputting labeled data, learning patterns, generating predictions, comparing outputs, and optimizing accuracy. Algorithms include regressions and neural networks. It features classification for discrete categories and regression for continuous values. It offers high accuracy for structured data, but requires massive labeled datasets. Applications include medical diagnosis and speech recognition. What is unsupervised learning? It works with unlabeled data to discover hidden patterns and structures without predefined correct answers. Dimensionality reduction preserves vital info. The system analyzes unlabeled data, groups it automatically, and uncovers hidden insights. Core techniques are clustering and association. It allows high automation, but is computationally expensive with a difficult reward design. Applications include self-driving cars, robotics, and resource management. What is reinforcement learning? Here, an intelligent agent interacts with an environment, learning through actions, rewards, and penalties to maximize success. The loop contains 5 main components: the agent, environment, action, reward, and policy. Popular algorithms include Q-learning and deep Q networks. It is widely used in robotics, autonomous vehicles, and industrial automation. To summarize, supervised learning maps label data for classification and regression tasks. Unsupervised learning finds hidden structures via clustering and association. And reinforcement learning uses an interactive reward loop to train autonomous decision-making agents.